All right, for topic 3, we're now solving the polynomial equation, and we're going to solve it by factoring. You might need to refer to these notes right here, where we follow these 3 steps, and we did some examples. Remember, we always want to set the equation equal to 0. Factor, we have to choose the best method. Then we're just going to set each factor equal to 0 and solve for x. So on this first problem here, if you notice, it's already equal to 0 here. And what we have here, this x, let me make sure this is working, because it doesn't seem, there we go. And this parentheses x minus 8, and this x plus 2 equal to 0. These are all the factors. I'm just going to, and this is that one and that one. This is just the factor form. So what we could do is set each one equal to 0. So I'm just going to create this little table here. So our first one here, we're just going to set x equal to 0. And then for x minus 8, make that equal to 0. And to the other one we have the x plus 2 equal to 0. And we're just solving for x. Now, we know some of you can do this mentally, and you can just get to your solution, especially when there's no coefficient in front of the x. But on this first one, this is our answer, x equals 0. On x minus 8 equals 0, we're solving for x, so we have to add 8 to both sides to isolate the x, and this one is x equals actually a positive 8. And that's what I'm saying, you can do this mentally, because in this binomial, x minus 8, we end up always doing the opposite. So since it's minus 8, the solution is going to be a positive 8. And then over here, since we have x plus 2, yes, to solve for x, we would have to, we would have to subtract the 2. And so, yes, x equals a negative 2. So our two solutions are our three solutions, excuse me, x equals 0, x equals a positive 8, and x equals a negative 2. Okay. Now, if you look at number 19 here, let me get to that page. Now, in this equation, it's not equal to 0. So our first step here is to make this equal to 0 by subtracting the 64x to both sides of the equal sign. And now this over here is 0, so I'm just going to rewrite this in standard form. We would have 25, x to the third minus 64x equals 0. All right, so now we're going to solve by factoring. And here we have a GCF. Always check for that too first, and that is this x that they have in common. So this would be simplified to 25x squared minus the x's cancel here, 64, and that's now equal to 0. Well, we're going to factor completely, and hopefully you see here we have a difference of squares. So we need to simplify that by taking that square root of the first and last term and writing the binomials with one positive and one negative. So this is still, our GCF is still one of the factors. This now becomes 5x minus 8 and 5x plus 8. And now I'm setting that equal to 0. So my solutions are what I'm solving here. Let me come down here. X is one of the factors. We're going to make that equal to 0. Well, that's one of our solutions. But this 5x minus 8 is going to equal to 0. And we're going to solve for x. Now when we do that, we have to isolate the variable term, that 5x, by adding 8 first on both sides. I've kind of run out of room here. So this is going to turn into 5x equals 8. But then you're going to have to divide both sides by 5. So I'm just going to come up here. One of our factors is x equals 0. That's the first one. Then we're going to get x equals 8 over 5. I noticed since this was minus, this became a positive 8 over 5. But over here, since this one is plus 8, this solution is going to be, if I work it out, it's going to equal a negative 8 over 5. So this, I'm just going to write it as a plus minus, because I want positive and one negative, of 8 over 5. That's the, so there's three solutions: the 0, the positive 8 over 5, and the negative 8 over 5. Okay, but you can show both by using just the plus minus. Now on 21 here, I'm just gonna erase this so I can have some room. It's already equal to 0, but we have 4 terms here. So hopefully you recognize you have to factor by grouping. Okay. So our GCF of our first term here is the x squared. And our GCF of the next grouping is 4. Alright, so I'm going to take out the GCF x squared. This is going to leave me with 4x plus 5. And I'm going to have minus 4. I'm going to have 4x plus 5. This is equal to 0. Now this is what we want. We want to make sure we end up with a common binomial. The 4x plus 5 is one of our factors. And our other factors are the GCFs. So that would be x squared minus 4, and that is now equal to 0. Now, hopefully, you see here, this is a difference of squares. So I can factor further. So we're going to keep the 4x plus 5 as one of the factors, but now this is going to take the square root, and we get x minus 2 and x plus 2 equals to 0. Okay, so we're going to solve each factor here. So this is the 4x plus 5 is going to equal to 0. We're going to solve for x. Now I think some of you see a shortcut, because basically if I have a coefficient, that's this number in front of x right here, you're going to always end up dividing. That should be a negative, sorry, to isolate that x. So this solution is going to turn x equals a negative 5 over 4. Now, remember, we can do this, work smarter, not harder. We can simplify it as just x equals, we got minus 2, so that's a positive 2. And here, since it's plus 2, that's going to be a negative 2. So there's 3 solutions here. The positive, excuse me, or no, did I miss my sign again? I did. The negative 5 over 4, sorry. The positive 2 and the negative 2. So some people might, and I'm going to write it over here, would write this x equals negative 5 over 4 and x equals the plus minus 2, like that. Okay. So, and that is the solutions for 21. Now, on 23, it is not equal to 0. So the first thing I need to do is add 3 to both sides of the equal sign. Now we get 6x squared minus 13x plus 6 equals to 0. Alright, so now we're going to factor, but this trinomial has a coefficient of 6. So we have to slip and slide and multiply. So this coefficient 6 times the c, which is 6, gives us 36. So we're looking for factors of 36 with the sum of a negative 13. That would be a negative 9 and negative 4. So I can write this as x minus 9 and x minus 4 equal to 0. But because we multiply, we slide over. You can't forget to divide by our coefficient. So we're dividing by 6. And here, these fractions can be reduced. Now, we don't need to put this in factor form. We just need to reduce this binomial. So I know they have 3 in common. So really this becomes x minus 3 over 2. And here they have 2 in common, reduce it by 2. And this would be x minus 2 over 3 equal to 0. So because we're solving, I don't need to do bottoms up. That's the factor form. I need to solve each of these factors. So this x minus 3 over 2 is equal to 0. And x minus 2/3 equal to 0. Yes, hopefully we see the shortcut. Remember, if there's no coefficient in front of the x, then we just have to do the opposite of that sign here. So that means my solution is x equals a positive 3 over 2. And over here, x would equal a positive 2/3. Okay, we have 2 fraction solutions. All right, and the last one we'll talk about in this section is another problem. Oops, did I go the wrong way? Hold on. Okay, sorry about that. It is 25. Again, this is not equal to 0. So we're going to minus the 18x to the third. That's to the third, sorry. And that's to the third. We're going to add 81x. So these can eliminate and make it equal to 0. So that's gone. We now have a 0 over here. So we're just going to put this in standard form. The x to the fifth is going to come first. The next highest exponent is this negative 18x to the third, so minus x to the third, then plus my 81x equals 0. Now we have a GCF here. Each term has an x in common. Okay. Oops. Sorry about that. Let me fix this. So x parentheses, when we're dividing exponents, we just subtract exponents with the same base, sorry. We just subtract. So this is now x to the fourth minus 18x squared. X is canceled, so plus 81 equals 0. Now, this is a basic trinomial. Even though we have an exponent of 4, if you want to do substitution first where you let the u equals x squared, I'll show you what that looks like. So this would be u squared minus 18u plus 81. But it's a basic trinomial because we're still just finding factors of 81 with the sum of a negative 18. That's a negative 9 and a negative 9. So my factors are the x, there is the GCF, and then we have x minus 9 and x minus 9 equals 0. Remember, this is actually x squared, because if I do u squared and take the square root, or not the square root, but when I factor it, I'm left with u. I probably should have just showed that. I'm left with u, show it with the u first. U minus 9 and u minus 9 are 2 factors of that. I forgot. Minus. And then I could substitute right here, since the u equals x squared. I could change those u's, and I'm just going to erase them and change them to the x squared, which is what I had written before. So we have x squared minus 9 and x squared minus 9 are 2 factors of x squared minus 9, and this is also a difference of square roots. Sorry. So I have basically the GCF, x is a factor, then we have x minus 3 and x plus 3. But that happens twice. I'm just going to write each factor form first. But these are all the same factors. So our factors, our solutions are x equals 0. That's that GCF. And then these two are the same. And they don't have a coefficient. So we just have to do the opposite. So we have a plus and a minus 3. And there's our factors. All right, so that takes care of this section. Check your answers on Wayground for the evens, and then we are going to wrap up with the topic 4.